All right, we're going to start a new unit today, unit 3. All right, so we're going to go over law of sines. And let's start with notes.
I have it for this unit and then like I want it a lot and
Okay.
Are we gonna have to do proofs?
Huh?
Are we gonna have to do proofs?
What do you mean?
Are we gonna have proofs this unit?
Oh, you mean quiz or proofs? Maybe on review days.
On review days?
Yeah.
So just like explain the process.
You mean just be able to work together in groups? Is that what you
Well,
mean?
for proofs, like you said, just on review days.
Yeah.
Just to like kind of better understand.
Right. Because I have to be able to. Okay. Yeah, we'll see. Okay. So let me just start off with notes here. Right triangle trig can be used to solve problems involving right triangles. However, interesting problems involving non-triangles can also be solved. We'll be using right triangle trig to develop law of sines. Law of sines is important because it can be used to solve problems involving non-right triangles as well as right triangles. So we also have law of cosines, but we're going to start with the easier ones here, law of sine. Okay. We know that we can use SOHCAHTOA to find missing sides of a right triangle, but our focus here is non-right triangles. We can also solve for missing sides or missing angles. Okay, so it says consider the oblique triangle ABC. That just means a non-right triangle. Okay, so the first thing is we're going to sketch an altitude from vertex B. So we have uppercase letters to indicate angles, and then lowercase letters to indicate the sides opposite that corresponding angle. So angle B, side, lowercase b, angle A, opposite side is lowercase a, angle C, opposite side is lowercase c. Okay, so we're going to draw from angle B to the opposite side. Just going to try our best to create what we think is creating a 90-degree perpendicular line with the opposite side. Okay, so we should be able to create two right triangles. And so the whole point right now is we're going to try to create this rule that we're going to be using called law of sines. Okay, we're going to label this altitude. Okay. So it says the altitude creates two right triangles inside triangle ABC. Notice that angle A is contained in one of the right triangles. So there's angle A for right triangle on the left. And then we have angle C on the triangle, smaller triangle on the right. Using right triangle trig, write two equations, one involving sine of A and one involving sine of C. So remember, SOHCAHTOA. So sine is what? Yeah, opposite over hypotenuse. So sine of A is equal to K over C. Opposite side over hypotenuse. Okay. Sine of C. What about sine of C here? Yeah, opposite over hypotenuse here. Okay, it says, notice that each of the equations in question 3 involves k. Okay. And why does that happen? Well, because both triangles share the same opposite side. Solve each equation for k. We're just going to cross multiply here. So I can always create a fraction by putting a 1 beneath here. So here I can say k is equal to c sine of a. So I just want to make sure that that c is representing a side length, not an angle. So that's meant to be lowercase c sine of a. And then likewise, with the other equation, k is equal to a sine of c. So now that I have two equations, both involving k, we can set the two equations equal to each other. And it's possible because they're both equal to k. So c sine of a is equal to a sine of c. Notice that the equations in question 5 no longer involves k. Rewrite the equation in question 5. Now we want to group the a's together and the c's together. We can have the either the sides up top or the angles above in the numerator, but typically it's written with the sides in the numerator. So we're going to take sine of a, divide it over to the other side, and then we'll also move sine of c at the same time. So I have c over sine of uppercase c is equal to a over sine uppercase a. Okay. We're really just working towards the formula that we're going to be using. But right now it's just kind of showing where or how to arrive at this formula. Okay, we're going to do the second half on the other page, second page. Anybody still need to look at these notes? Okay, go to the next page. We'll follow the directions again. For this time, we're going to sketch an altitude from vertex C. So from angle C, we're going to drop an altitude to the opposite side, C. Everybody good on this page? Okay, we'll go ahead and label this K as well. Same idea. We're going to create a trig equation involving sine A and sine B. So sine of A is equal to what? K over B, opposite over hypotenuse. Sine of B is equal to K over B. Okay, same steps, cross multiply, solve for K. Now that both equations are set equal to k, we know we can set them equal to each other. We'll divide the sine A over to the right, divide sine of B over to the left. We're just going to group all the A's together, group the B's together. Now from the previous page, we know that C over sine C equals A over sine A, so we can link them all together. Now, anytime we're solving a variable, we're only going to be grouping two together, but we always have the choice to either pair A or B or C or A or C, depending on what the problem is calling for. Okay, so together, the equations form this law of sines. Law of sines is important. It can be used to solve problems involving both right and non-right triangles. I think for us, we're going to see a real benefit more with the non-right triangles. It involves only the sides and angles of a triangle. All right, so we're going to basically just be practicing with this rule on the practice page. Okay, so whenever you're ready, next page. Yes. You could, yeah, you could have it flipped. Sine of A over A, sine of B over B, sine of C over C. It's just typically written this way, but it wouldn't be wrong if you flipped it. Okay. Okay, so we're going to be given some various information about size of our triangle. We're going to start off by sketching our triangle here. Now, it doesn't have to be accurate in terms of the angle measures, but we'll just try our best just for visual purposes. So let's say I call this upper angle 40 degrees. Let's say I call this angle A. I want to mark angles A, B, and C. Angle C, I'm going to call this 70 degrees. Okay. I'm going to label the opposite sides as well. You know that if angle A is 40, the opposite side, you see that lowercase a, that means 20 is going to have to be over here. Again, the lowercase letter is always going to be opposite the corresponding angle, uppercase letter, which represents angle. So we can also label the other sides as well. We are looking for side B. We're also looking for side C. Okay, let's start with the easy things first here. Can we find this missing angle? Okay, how to do that? We know that all angles of a triangle add up to be 180, so if we subtract from 180, we can find that missing angle, which is also 70. Okay. So here we have an isosceles triangle. So the advantage here makes the problem easier is that we know that the legs will be the same size. So if we just find side B or side C, we know the other one as well. Okay, so this is how I want us to set up. I think this is the most efficient way of working through it. They don't have to be in order. Okay, we don't have to have A sine A on the left and then B sine B on the right. But the way that we're going to choose is we're always going to have to involve an angle and side that is completely known. Okay, so we definitely, if we want to find either B or C, we have to involve A. If we try to do sine B over sine B equals sine C over sine C, we're going to be left with two missing variables, and that's not going to help us. Okay, we always want to have a full known information from one of the angles and the corresponding side. Okay, so anytime for this problem, we're always going to have to involve A over sine A. Okay. I'm going to target B first. So the way I think is the cleanest way to do this is I want my missing variable on the left side. So I'm going to set it up this way. B over sine of B is equal to A over sine of A. Again, I'm choosing A and sine A because I have full information here. And I'm just choosing B because that's just the first thing I saw. I want my missing variable here. And I'm going to fill in the rest of this. Okay? I'll say B over sine of uppercase B. I know my angle B is 70. Side A is 20 over sine of 40. Okay. We know that we can solve for B because that's the only variable we have left here. Okay. Everybody okay so far? Okay. Now, the next step is we cross multiply and we solve for B. But I want to show you a little bit of a shortcut here. This does the same thing as cross multiplying, but notice how we're solving for B. B is in the numerator. We really just have to find a place for that sine of 70. So really that sine of 70 is just going to be with the 20 here. So you can just cross the sine 70 out, put it in the numerator space next to 20, and then you already have B by itself and you're ready for your calculator to find your approximation. Okay, does that make sense? It's the same thing as cross multiplying. We're just kind of saving a little bit of rewriting. Just take that denominator, move it to the other side, the numerator. And now we already have B by itself on the left side. The right side is just entering the calculator. Now, when you enter in the calculator, what mode do we have to be in here? Degrees, right. 40 degrees, 70 degrees. So make sure you're in degree mode. So go to mode and make sure that DEG is highlighted and not RAD. The rest goes in your calculator. You guys get that? 29.238. Right. That's our. Now, typically, we would do the same thing with C and sine C paired with A over sine A. But because this is an isosceles triangle, we know that B and C are the same. We don't have to go through that extra step. Okay, any questions? Okay, so again, here are the steps. We're always going to draw the triangle first, label as much as you can. Uppercase means angles, lowercase means opposite sides. Fill in two of the angles given. Find that third missing angle, subtract from 180. And then put the known information on the right side and then the unknown proportion on the left side, or the unknown fraction on the left side. And then once you fill everything in, you're just going to move that denominator on the left to the right side, and then you're ready for your calculator work. Okay. Okay, I'll set up part B, number 2 and then see if you guys can finish it. Again, your triangle may not look like mine. It's okay. You know, I want to target that obtuse angle there because the 100. Okay, first things first, find that missing angle. Subtract from 180. Now we want to choose a pair of variables to set equal to each other. But no matter what we do, we have to involve what? We have to involve B. Good, right? We want something that has full information. I'm setting everything up, but you guys can just jump directly into filling that in. Okay, so fill that in. You should be able to get that A being the only variable sitting there, and then just shift that sign A to the right. Okay, so I want to kind of walk around, see how you guys are doing with this, and then I'll show the answers. And then after you get done with 2, then go to 3. I'm going to try to get through these 5 problems. Guys, make sure you bring your calculators tomorrow. Double check that you're in degree mode. Set up another proportion. All right, so let me show number 2. You are good with 2. Go ahead and move on to 3. I'm sorry? No. I think just, I mean, the more accurate that you can make your triangle, I guess the easier it may be from a visual perspective, but I won't be grading the accuracy of your triangle. It's just there to help you out. Okay, if you're done with 2, check 3. Okay, number 4. If you're working ahead, you can try the word problems as well. The word problems is just the same thing. It's just he's going to be drawing a triangle, but they're going to be giving you descriptions to fill in different sides or different angles. We'll finish this. I don't think you'll have homework tonight. All right, here's number 5. Any questions with 5?
Why some of the higher
Okay, let's look at number 6. You're creating a triangle much like the same way as 1 through 5. You're just so number 6, you're going to draw a right triangle, very similar to number 5, where you know that one angle is going to be obtuse angle. Fill out the other sides, and then we just have to find the missing sides. And then part C is just asking for the perimeter of the triangular plot. So it's just like solving for the 2 missing sides and then adding up the 3 sides at the end. So not very different from 1 through 5, just in a word problem format. Any questions with 6? Yeah. Oh, sorry. 95 degrees is your largest angle. Yeah, not right now. You can label them however way you want to. I just chose those arbitrarily, but you can use different letters if you like.
Oh,
The only use of diagram theory is the right triangle. Here, this is not a right triangle, so we can't use the diagram theory. Okay, is everybody okay with 6? Give you guys another minute. Yeah, just add up the 3 sides. Okay, next page. So number 7, let me just help you set up the diagram. So let's just think of a mountain as a shape of a triangle. We got a cable car that is going up and down the mountain. The track is used by the cable car, has an angle of elevation of 30 degrees. And then the angle of elevation from a point 100 feet from the base of the track. So that's going to be some distance away. We'll call it 100 feet or 100, yeah. And then we'll create another triangle. This is really the triangle that we want to work with here. And ultimately, we're trying to find the length of the track. So let me highlight the triangle that we're working with. But there's a missing piece that we need to find is this angle here. How do you think we can find this angle here? Yeah, linear pair, right? Linear pair involving, we know along a horizontal line. All angles have to be 180. So if this is 30, then this must be. Okay, so now you're just going to find this missing angle, and then you should be able to use law of sine to find that missing side x. Yeah, so find this top angle first, and then you can set up using law of sines. Okay, here is number. Okay, any questions here? Were you guys able to get the same answer I did? Well, yeah, let me talk about that. So the checking quiz will be really short. It'll be one problem. It'll be similar to 1 through 5. I'll just give you two angles, one side, and you just want to have to find that missing angle and two missing sides. But it'll be really short. That'll be at the beginning of class, and then we can move on to the next lesson, which is the ambiguous case involving law of sines. But we'll spend the first 5 minutes doing a practice problem, making sure that you guys are good and comfortable, and then we'll do our check-in quiz. Again, just one problem, not a real problem. It'll be similar to 1 through 5 on the first page. That's right. One of those 1 through 5. Okay, no homework tonight.